This video is going to talk about hydrogen ion concentration and pH. So we're going to pick up right here in the notes on the PowerPoint. And so we were talking about the beginning of the last video, we were talking about the dissociation of water and how it forms hydrogen ions or hydronium ions. Remember, they can be used interchangeably, and hydroxide ions. So when those two water molecules collide just right with enough force, they form that hydronium, H3O+, and they form the hydroxide. And when you're looking at a sample of water, that chance of collision and that chance of self-ionization of the water happens very, very rarely. So it's a very small extent that we form that hydronium and the hydroxide ions. And when we look at this, so water is forming the hydrogen and the hydroxide. That's why, again, it's not considered an acid or a base. And the concentration of each of those in a sample of water would only be 1 × 10⁻⁷. So again, that's a very, very small amount of hydrogen ions and hydroxide ions in solution. Because these are equal to each other, and because it's producing both the hydronium and the hydroxide in equal concentrations, this is a neutral substance. It's neither an acid or a base. So if something is producing more hydrogen ions than this 1 × 10⁻⁷, or if it's producing less hydrogen ions than 1 × 10⁻⁷, that's how we know if something is acting as a base or if something is acting as an acid. So when you look at here, the acidic solutions have a lot more of the hydronium, or remember that's the same thing as the hydrogen ions. It has a lot more of those ions present in the solution than it has the hydroxide ions. So because it's making more hydrogen ions than hydroxide, the concentration of the hydronium ion would be greater than that 1 × 10⁻⁷. Remember, that number is based off of the self-ionization of water, and that would be equal concentrations of hydrogen and hydroxide in a neutral substance. So since acids produce hydrogen ions, it would make sense that the hydrogen ion concentration would have to be greater than this 1 × 10⁻⁷ in acids. In bases, though, remember, bases are going to accept a hydrogen ion, and because of that, they're going to be producing more hydroxide ions because they're taking away the hydrogen ions from that self-ionization of water. So with basic solutions, the hydroxide ion concentration is going to be greater than that number, all right? So acids are going to make more hydrogen ions, bases are going to make more hydroxide ions. So when you look at these down here, letter A, we have the hydronium ion concentration is equal to 1 × 10⁻�3. We want to pay attention to these exponents to remember what those mean. So this is actually a larger number than 1 × 10⁻⁷. So this first one would be an acid. In letter B, if our hydrogen ion concentration is 1 × 10⁻11, -11 power is very small compared to the -7th power. So this is actually a base because we have a very little amount of hydronium ions. Letters C and D talk about the hydroxide ion concentration. So in letter C, the hydroxide ion concentration is 1 × 10⁻⁴. When you compare that to 1 × 10⁻⁷, that's more hydroxide ions. So since it has a lot of hydroxide ions in solution, it's basic. And then letter D, 1 × 10⁻13, that's a very, very small number. So it has very, very small amounts of hydroxide, which means it has a lot of hydrogen ion concentration, so this would be acidic. So it's very hard sometimes to talk about the hydrogen and hydroxide ion concentrations because we're dealing with such small numbers, and we often refer to those in scientific notation. So we have a pH scale that helps us to reference these ion concentrations in a more usable way, more user-friendly. So when you're doing your acid and base project, you should be researching the pH scales, or the pH ranges rather, of your acids and bases. pH is usually referring to the power of hydrogen. So it's talking about the hydrogen ion concentrations. Because bases have very little hydrogen ion concentrations, you can see that with your bases that have very little hydrogen ion concentrations, they have a high pH. And you can see for your acids that have a higher hydrogen ion concentration, they have a low pH. All right, so these are opposite of each other. If something has a high hydrogen ion concentration, it's going to have a low pH. And if it has a high hydrogen ion concentration, it's going to have a low hydroxide ion concentration. So remember, bases have low hydroxide ion concentrations. I'm sorry, they have low hydrogen ion concentrations. They have a lot of hydroxide ions. So they have low hydrogen ion concentrations, which means they have a high pH. Acids have a high hydrogen ion concentration, and they have a low pH. With your neutral substance, you can see that the hydrogen and the hydroxide ion concentrations are the same. There's also something called the pOH scale. So the pH scale is talking about the hydrogen ion concentration. So what does the pOH scale talk about? The pOH scale is representing the hydroxide ion concentration. So essentially, the pH scale and the pOH scale are opposite of each other. And when you look at this image over here, you can see that inverse relationship. So your acids that have low pHs are going to have high pOHs because they have a high hydrogen ion concentration, but they have a low hydroxide ion concentration. And your bases up here that have low hydrogen ions have high hydroxide ions. And so you can see that relationship between the pH scale and the pOH scale. So they're opposite of each other. Ion concentrations and their scale are opposite of each other. They're all inverse relationships. When you're looking at the pOH scale, when we're talking about high pOH, we're talking about low OH concentrations. When we're talking about low pOH, we're talking about lots of hydroxide ion concentrations. Kind of the opposite of what we were discussing with that hydrogen, or that pH scale rather. So you're going to answer the questions on page 9. They're all conceptually based questions about pH and pOH and hydrogen ions and hydroxide ions. Next week, we'll start talking about the actual calculations involved with the pH and the hydrogen ion or the hydroxide ion concentrations. So if y'all have any questions, just let us know and we'll see you later.